our variable is the, yeah, but what does that x represent? The angle. So when you're solving trig equations, your answer is going to be the angle. That's why I asked you to hopefully refresh the unit circle, which apparently I should have had a quiz prepared. I had a couple of disappointed students, no quiz prepared.
Yes, disappointed students.
So if you look at the first equation, we start out with baby steps so that you get the idea of what we're trying to solve. We have 2 sine x minus 1 equals 0, which is really just saying 2x minus 1 equals 0, except we have a sign in there. But you're going to solve it the same way you would solve an equation for x. So we're going to apply the same properties that you would in algebra to solve trig equations. So how would you solve that equation? 2 sine x minus 1 equals 0. Colin?
Would you add 1?
You would add 1. Remember, you're trying to isolate the variable. That's what we say. Get the variable by itself. Dylan, you would then divide by 2. So in this case, we're isolating whatever the variable's with, and it happens to be with the function sine. So now I have the sine of x is equal to 1/2. That's as far as we're going to go by isolating the variable, because now we're going to refer to the unit circle. So the sine is by itself, the variable is attached to it. So we're thinking about the sine of an angle that is equal to 1/2. It says we're writing our answers in 2 different ways. Part A says we're going to write a specific solution from 0 to 2 pi. That means I need to find all the angles from the unit circle from 0 to 2 pi. And then we're going to try and write a general solution so that I can find an infinite amount of angles if I continue to rotate around the unit circle. So going back to the unit circle, we need to think about the sign. Is the sign the x or the y on the ordered pair of the unit circle? So the sign x, y. Okay, so sign is y. So this is my ordered pair, at least the y of the ordered pair. If the y is 1/2, what's the x, Hannah? Square root of 3 over 2. So then we need the angle that's attached with that ordered pair. Do you know what it is, Hannah? That is a pi over 6 angle. Oh, yeah. No. Oh, yeah, pi over 6. You're right. I'm sorry. Pi over 6. I apologize. All right, so is that the only answer? Because it says find the angles in the interval of 0 to 2 pi. Dylan, where else could a sine B have that same y value? Quadrant 2. So in quadrant 2, I could still have a positive 1/2, but a negative square root of 3 over 2. So we're looking to see when is y positive. Well, y is positive in the first and the second quadrant. Sine is positive in the first and the second quadrant. So now we need to find that same pi over 6 angle, but it needs to be in the second quadrant. And Hannah, that would be 5 pi over 6. So if you need to have that little unit circle out so that you're looking at it, it might be helpful, but like we're going back to that material from chapter 4 now, we're using that information. So these are the specific solutions for part A. Specific means the actual angle value. Those are all the solutions from 0 to 2 pi, because sine is positive in 2 quadrants, it would be negative in 2. So I'm only going to have 2 answers. Everywhere else it's negative. The next part says to write a general form. So a general form means if I could spin around the circle 5 times, what would my angles be? And the way we write a general form is by setting this still equal to x, still using that same initial angle, but then adding 2 pi times n, or subtracting 2 pi times n. Now, why would I do that to make a general form? Why would I add 2 pi times n?
Because circle is 2 pi, radius round, so if you go that much further, you end up.
Excellent. So if I take my angle, and as he said, go that much further, you end up back at the same place. We've just added an extra 2 pi. So we have the same angle, it's just bigger. The n on it, why would I put an n on there? times you go around. So say I want to go around 5 times or 10 times. I have a minus there because we could go in the minus direction as well. So that is called a general equation in trig form. So now it says any angle with pi over 6, if I add 2 pi times an n, maybe times a 4 or a 5 or a 6, depending on the number of times you want to go around, then we have a general form. So you could find an infinite amount of angles. So the question might say, find the first 5 angles as you spin around the unit circle. And I would use that to help get the 5 angles. So we need 2 of those general equations because we have 2 different angles. So besides the pi over 6, we have the 5 pi over 6. That's in a different location. So from that location, I also need the general form, and you're still adding 2 pi in. And again, Colin said that you're going around 2 pi to get the whole way around the unit circle. You could also say the period of sine is also 2 pi. So to get back to its starting point, to repeat the graph, I would add 2 pi as well. Questions?
Is it just addition for the second one?
Sitting, I missed my minus things. Good catch.
Okay. Attaboy.
Any other questions? So we're isolating the function that's contained in the x, and then you're looking at the unit circle and getting the angle solutions. So the second one, I said the first one we were going to start baby steps. So the second one looks a little more interesting. We have the cotangent times the cosine squared, and that's equal to 2 times the cotangent. So we cannot divide variables or functions, because when you divide by a variable or you divide a function, you lose the part of the solution. You literally, if you're dividing them out, then you don't have those answers. They're like poof, wiped away from the equation. And that is the same thing for x's. If we divide out x, you're losing that possible solution for x. So we're not going to divide. But we are going to subtract it. We're going to set it equal to 0. So you either isolate the variable or you set it equal to 0 and you do some sort of factoring usually with it. So we're going to set this equal to 0. So literally we're going to subtract the cotangent to the other side. So equations, there really is like 2 ways you solve an equation. You either get to isolate the variable or you set it equal to 0. Zero product property. Says if you factor something, then each of those products can be set equal to 0. So Josh, how could you factor this? Yeah, they both have a cotangent in common. So we could take out a cotangent. Say we're not dividing by the cotangent, because then we would lose that answer. But you're still pulling it out. Staying in the problem. So that will leave us with cosine squared minus 2. So dividing it out really means factoring it out. You're keeping it in the problem.
Can you turn that into 2 sides?
We're actually going to just keep it as is.
Can you do that though?
Can you turn this guy here? No. So it is not 2 times the sine. It's not an identity unless it's just sine squared plus cosine squared equals 1, or all of it's multiplied by 2. Other questions? So the zero product property says when something is factored, you're allowed to separate them and individually set them equal to 0. So it's now factored. We can separate these and individually set them equal to 0. So cotangent is equal to 0. Cosine squared, I'm going to just pull the 2 to the other side, would be equal to 2. Zero product property. Once you have a product, multiplication, you're allowed to split them up and individually set them equal to 0, as long as the equation is equal to 0. And then if you solve for this cosine here, what would that cosine be equal to? Yeah, take the square root of both sides. Put a plus or minus because we took the square root. So still the same algebraic properties apply. If you take a square root, your answer is plus or minus. So now we have 2 functions to worry about. Both functions contain angles, so both x's could functions is going to kind of decide how many angle solutions you have. If you look at cotangent first, cotangent is what over what? Cosine over sine. So cosine over sine. So that means our cosine is 0 and our sine is 1. Or you could say on the unit circle the x is 0 and the y is 1. So where on the unit circle would the x value be 0 and the y value be 1? So when is x 0? So x is 0 right here. Where else is x 0? Down. It's negative 1. Is that okay? Can I have 0 divided by negative 1? Does it still make 0? Yes. So both those angles would work. I could have 0 divided by 1, or I could have 0 divided by negative 1, and I still get 0. So the angle at the top, that's pi over 2. The angle at the bottom is 3 pi over 2. I'm going to just separate this. So that would be my answers for the cotangent side. I have two different functions. So I have solutions that correspond with cotangent of 0, when the cotangent is equal to 0. Looking at the other side, we have cosine being equal to plus or minus the square root of 2. Carry. Why?
Because it's bigger than 1.
So Carrie said that that number is bigger than 1. And it's also less than negative 1. Cosine only goes between negative 1 and positive 1 on the unit circle. So if it's outside of that range, then there is no solution. So this side doesn't give us a solution. There aren't any angle answers because cosine and sine only go from positive 1 to negative 1, negative 1 to positive 1. So that means I have those two angle answers, pi over 2, 3 pi over 2. So going back to look at the question, it says to write the specific solutions from 0 to pi of 2 pi, and then it says to write the general form. So our specific solutions, the angles, would be pi over 2 and 3 pi over 2. So those will be our specific angle answers. We need to write that in general form as well. So the next part, we have to write those angles in general form. So how would you write those angles in general form? Hannah?
X equals pi over 2 plus or minus 2 pi n.
So she started with pi over 2, and she said plus or minus 2 pi n. What's special about those angles? Not quite, you're close. They're across from each other, right? They're exactly across from each other. Garrett?
So could you just do plus pi n?
Yeah, you could do just plus pi n.
Oh my god, dude.
So if you continue to add pi, I would get to 3 pi over 2. If I add another pi, I would go back to, it would be 5 pi over 2, and then I have 7 pi over 2. So instead of writing two equations, because they are diagonal from each other, and this works for tangent functions, so because they're diagonal from each other, you have one general equation with a pi n.
So do they have to be straight?
Yes. So on a test, I would mark it wrong.
So do they have to be like straight lines?
Yes. Yeah. So if they were both, like if I had pi over 4 and 5 pi over 4, so if they were both diagonal from each other. So they have to be a straight line diagonal across from each other. And that works for tangent. Does anybody know why it works for tangent? What's the period of tangent and cotangent? It's pi. Yeah. question so far? Okay, so we're gonna do a little more factoring.
Yes.
Looking at the next page. So this problem wants us to solve the equation, and that's pretty much the directions of tonight's homework. It'll say solve the equation. But it says the solution should just be in the interval of 0 to 2 pi. So that means I don't need a general equation. We just need to write it as an angle, whatever that solution would be. What form does your equation look similar to if you think of algebra? So Brenton, thinking algebraically, what does this look really similar to? Standard form, yeah, of a quadratic. So it looks like 2x squared minus x minus 1. Looks like ax squared plus bx plus c. That's standard form of a quadratic. So Brenton, how would you solve an equation that looks like standard form of a quadratic? AC grouping. So a times c is negative 2. Two numbers that multiply to be negative 2 but combine to be negative 1. Negative 2, 1. So instead of using x when we factor, we're using the sign along with it. So we have 2 sine squared x using AC grouping. And then a negative 2 sine x, a positive 1 sine x, and then a minus 1. If you don't want to write the sine x, that's fine. Feel free to factor it with the algebra and put this sign back in your factor form. So continuing the AC group, Brenton, what would we pull out of the first pair? And a sign. And what do you have left? Good. And then the second pair we just have just a 1. Yeah. Good. So AC grouping, pull the two pairs together. So 2 sine x plus 1. And then sine x minus 1. So factoring it. Again, if you don't want to factor it with the sign in the problem, factor it out regularly with x. But it's that standard form. So zero product property, once it's factored, you can then solve. So solve for each of those, which means get the sign by itself. That's what solving really means in terms of trig. You're trying to get sine x by itself. So the sign would be equal to, and the other sign is equal to 1. So again, two different things you're finding. They're each going to give you different angles. So the sine is equal to negative 1/2. The sine is equal to 1. So we're trying to find angles that correspond with both of those little equations. So we just talked about sine being y. When is the sign negative? Third or fourth. So third and fourth. So negative 1/2. So this would be a negative square root of 3 over 2, positive square root of 3 over 2. And then the sign is equal to 1. We just did this on the previous page as well. So those would be the two locations. 3 locations, actually. We just need the angles corresponding with those. Hannah, what do you think?
For the first one, 7 pi over 6, and then 11 pi over 6, and then that's pi over 2.
Perfect. So we factored using regular AC grouping because it was standard form. It was something that was squared. Ax squared plus bx plus c. After you factor, you individually solve for each factor, which is really what we do with x. You usually get x by itself, except now those x's have a sign function attached to them, so we have to do the angles. The hardest part is going to be remembering the angles. don't have to write it in general form because it just says interval from 0 to 2 pi. So that would be our solution. 3 angles. So see if you can solve example 4. And look to see what do you have, what's in the problem. How would you try and get to the answer? So factoring it or isolating the variable or the function. Those would be two common things that we would want to try and use. And this one says the solution should be in general form. So that means that plus 2 pi n or pi n, depending on what functions we have. You want to go back to the previous page?
Yes. Thank you.
Yeah.
Isolations of two sides.
Uh-huh. So if we add this sign to the other side, how many signs do we have? 2. X plus x is 2x. Sine plus sine is 2 sine. And now it's equal to 0. We added the like terms together, so it's equal to 0. We still need to isolate the variable, which means this needs to be by itself. We need to isolate that entire function. How would you do that, Lauren? Yeah. So take the square root of 2 to the other side, and then divide by 2. Because this doesn't have a squared term, you just have to get the sine x by itself. We don't have to worry about factoring it because there's nothing squared in the problem. So now we have the sine x is equal to negative square root of 2 over 2. So the sine part is by itself. We've done all of the algebra, and now it's going back to the unit circle. So from the previous problem, we said sine was negative down below. And we know sine is y. Lauren, what angles have a y value of negative square root of 2 over 2?
Is it 5 pi over 4 and 7 pi over 4?
Good. So she said 5 pi over 4. Pi over 4 angles, that's the family of angles. So if we have the square root of 2 over 2, square root of 2 over 2, those are pi over 4 angles. But we need that in the 4th quadrant and the 3rd quadrant. So she said 5 pi over 4 and 7 pi over 4. So the answer wants us, or the question wants us to write the solution in general form. So these would be the specific angles. Lauren, what would your general angles look like?
X equals 5 pi over 4 plus or minus 2 pi n.
Good.
And then x equals 7 pi over 4 plus or minus 2 pi n.
Excellent. So those angles are not going to be pi units across from each other because they're down in the bottom quadrant. So we have to add 2 pi to go all the way around to get back to that application. Questions? So I believe there is one final problem with tangent because we really haven't done tangent. I should have thrown in a cosine. Oh, we did have a cosine problem. We did cotangent, a lot of sine. Solve the equation 3 tangent squared x minus 1 equals 0. Write the specific solutions and then the general form. So generally, you need the specific solutions to get the general form because you need to know the angles to start with.
True.
Yeah. Can't have a general form without knowing the angles. think most of you took the 1 to the other side, divided by 3, took the square root, and when you take the square root individually, you end up with 1 over the square root of 3, which carries actually square root of 3 over 3. What else goes with that answer? Yeah, plus or minus. Because you took the square root. You were solving for something that was squared. So anytime you get rid of a squared term, you're applying the square root. We need a plus or minus in the answer. So we're looking for how many angles? 4. Because of the plus or minus. So tangent is positive in 1, and tangent is positive in 3. That's where tangent's positive at. But it's negative in 2, and it's negative in 4. Now this one's trickier because it's tangent. It's not sine or cosine. Remember, tangent is y over x. So we need an ordered pair from the unit circle that will simplify to become the square root of 3 over 3. Hannah.
I figured out 2 of them.
Okay.
Pi over 3 and 2.
So
Pi over 2. Square root of 3 over 2 and then 1/2.
okay, so it's not pi over.
Yeah.
Oh.
Sorry.
No, it's okay. So square root of 3 over 2 and 1/2.
Yeah. And
Okay.
then
So if we look at the square root of 3 over 2 and 1/2, how do you know that that makes the square root of 3 over 3?
because 1/2 over square root of 2 is
Yeah. So she said 1/2 divided by the square root of 3 over 2. Tangent is y over x, sine over cosine. So that does leave us with 1 over the square root of 3. So that angle that corresponds with that ordered pair is what? Pi over 6. So that would be our family of angles that corresponds with that ordered pair. So when you have tangent, you're going to have to think which ordered pair would simplify to be the square root of 3 over 3. So that angle would be pi over 6. So pi over 6 in the first quadrant. What angle would it be in the second quadrant? 5 pi over 6. In the third quadrant, 7 pi over 6. And in the fourth quadrant, 11 pi over 6. They're all the same angle. 2 of them are positive, square root of 3 over 3. The other 2 are negative, square root of 3 over 3. So those would be our 4 specific answers. But when you go to write them in general form, so specific values, all of those pi over 6. There we go. The reason it's all of them is, again, we took the square root, we had a plus or a minus. But now we want to write them in general form, and you don't need 4 equations for general form. You just have 2. Emma, do you know what 2 the general form equations would be? Yeah, so you're going to have an equation to represent these 2 positive angles, because they're together. They're 90 or 180 degrees across from each other. So the 2 positive, that pair, starting with pi over 6, because that's the first angle. If I add, bless you, or subtract pi n, then I can get to 7 pi over 6. So that's the positive angle pair. And then the negative angle pair starts with 5 pi over 6. And then again, just add pi n. So looking at the little picture over here, we can see that those angles are pi away from each other. So your homework is 8 problems tonight. What? 8. I know, right? Starting with 29 and going to 43, just the odds, not the evens. No calculator. All of your answers should be angle answers on the unit circle. And then the book has specific directions. I wrote them on the board. They're also there on the assignment sheet. But the first group of problems wants general equations, and then the second group, you don't have to write the general form, just be specific. Again, like you need specific answers to write general form. Anybody interested in doing 33, Dylan and Emma, 41? Dylan, you actually have, you're good, Dylan. Yes, Brenton, you want 33 instead?
I only have one. How many we need? 3?
Yeah. Yeah, we got a whole bunch of time. It's only week 25.
Only week. How many weeks do we get?
40. Sometimes 39, depending on how the year is
We end on the
sectioned off.
Send me the